long. Yes. Indeed, we're going to talk about introduction, or we're going to talk about observability, what it is, how we got here. And let's start with a little example. This is Bill. Bill is on call tonight. And Bill is going to have a terrible night because he doesn't know yet. He's going to be woken up in about 2 minutes. And when that happens, Bill is going to have a huge peak of adrenaline. And that means his blood vessels are going to expand because his body is going to start preparing for a fight, because that's how the human body is basically set up. It also means the body is going to start shut down things we don't need to fight or flight, which means the brain is going to be shut down for one of the things. There's several other things that's going to happen with the human body, but those are the most important bits. The brain is actually going to shut down for a while so that we can run faster. We spend our energy on running away. When Bill is woken up about these 2 minutes in, we're going to show him this. Right? We've been preparing Bill to be peak caveman. We need to run away. And then we're going to ask him to do a high cognitive task. Right? We're going to show him a dashboard, and somewhere on this dashboard, there is a value that is incorrect. He's going to have the option between a percentage, a gauge, a number, a gauge with a number, a gauge with a percentage. We're going to have a graph. I don't know, we have many opportunities, and one of these things is off. And that's actually entirely strange. This is not how incident response, I was told this morning, should work. But the problem's actually going to be worse, because Bill is not only going to be asked to look at the dashboard and find the weird number, the weird one out, he's going to be facing with a lot more stuff, right? We're in a modern world, so we're going to have Slack, we're going to have emails coming in, we might even get a call from the pointy-haired boss saying, why is it broken, when is it going to be fixed, and it needs to be fixed basically yesterday. And remember, Bill is still at peak adrenaline, right? He is ready to punch someone, but he's not necessarily ready to work out what is wrong. And classic monitoring systems will have the information in a very dispersed way. Right? We're going to have some metrics somewhere in the one system. We're going to have perhaps logs somewhere else. PagerDuty is going to tell us things which may or may not be accurate or may have some form of latency, or it's a flat out lie because something else in between is broken. So we're actually in a very bad state to fix our problems right now. And let's start. Do a step back. Hello, I'm Bram Vogelaar. I used to be a molecular biologist. I used to work at big pharma, big international universities, trying to work out why people die when cholesterol is in your blood instead of when it's good, when it's in your cell membranes. So, and as my colleague said, I slowly descended to the dark side because I first became a bioinformatician when big data became a thing. Big data is not the big data we think about, it's everything that does not fit in an Excel sheet. We were generating 200,000 data points per week, and you needed to do stats programming to get around it. In an academic world, for who are not familiar, when you're the developer guy, you're the server guy, so I picked up some operations skills along the way. And now I am a cloud DevOps engineer at the Factory Small consultancy company in The Hague. And the rest of the talk, I'm going to build up to how do we get to observability and where should it take us. But this is, to me, the highly opinionated history of monitoring way back when we used to do mostly SNMPs, checks that we pulled in from somewhere around the range of 100 things we would know about our system. And if we had logs, we used to save them in databases. So if the database exploded, it probably was we were logging too much. When I got into IT, we were looking at 1,000 series of time series that we were pushing into Graphite and StatsD. If you wanted numbers, Graphite, changing numbers directly to Graphite. If you want to counter, use StatsD. And Jordan Sissel just came out with Logstash to not have to store your logs in a database. Well, eventually it ended up in Elasticsearch, which was somewhat of a database, but it wasn't your MySQL anymore. And now we're getting to the point where Prometheus scrapes millions of metrics. So historically, we see a change, right? We do pull, we do push, then we're starting to do pull again. But we're looking at millions or even billions of metrics at the same time. Logs are literally everywhere, and traces are now a thing, meaning that architecture is now so broad, diverse, that we actually not entirely sure where in our system something is happening. We used to have an architecture, front-end, middleware, back-end. 3 places to look. Now we have microservices or other architectures where we have multiple data centers, multiple third parties we rely upon. So things got harder for us, although the move to the cloud is the promise to make everything simpler, but this is where monitoring sort of got stuck. And that's because historically, monitoring was an operations thing. Right? Developers wrote their code, committed it, and then the ops team was supposed to run it and monitor it. But since they had no idea what the application did, or roughly knew what it did, we have logins, people do some things, and we produce PDFs. So we were not necessarily monitoring what was going on in the system. We were monitoring what was going on in the OS, on the OS layer, but we weren't necessarily monitoring what was going on completely. The system could look fine, but the application on top could be burning, and we wouldn't normally be able to see it in our dashboards. This is roughly around the time that many CTOs woke up and found out they were actually running a technology company. The internet became a thing, web shops became a thing, web shops were actually making more money than the brick stores. So they had to decide, we are now a technology company, and we're making all of our money, or 70% of our money, with our web shop, and we're going to apply the same rules we were applying to brick stores. So we must have 100% uptime. We all know that's a myth. But we were trying to optimize our processes to get to this 100% uptime, which isn't feasible. But that got us into more problems where we got scared of deploying, because a change that never happens is not a breaking change. I mean, your disks still fill up. People dig up cables that go into data centers, so you still have problems, and that's where we got into trouble. But eventually, we are in a business of selling new stuff, so we need to get these functionality out in front of people. So we were saving up our changes. We deployed it once every half year. It took us 4 weeks to get there. So people got really scared about deploying. And then, as a reaction, we came to the age of just monitoring everything. This is becoming cheaper, we're getting SSDs, so we'll just monitor everything. But also at the same time meant the impact of the observer on the systems, and in many cases the tools were all not diverging, so we'll have a metrics thing, we'll have a logging thing, we have a competing thing running. So the actual overhead on a system was actually something you could pick up on the metrics. So the observer, the act of observing was actually changing the system. Thank you. The term monitoring love came up, and yeah, we're going to measure everything, but we're going to kill our CPUs, and we're going to basically kill our hard disks, observing it and trying to store it. Which meant we actually had a monitoring problem about our monitoring tools. Right? There were huge teams set up that basically did a lot of, who hasn't worked in an enterprise company where we had a monitoring team, and most of the time we spent monitoring the monitoring system, because we were the ones producing the most metrics, which is a very weird place to be in. And at the same time, everybody around us was moving to the cloud. And the guys at Etsy were coming out with their new strategy. We're going to deploy 10 times a day because our CI/CD is actually catching up with the cadence we want to do. But the monitoring tools weren't progressing. So we had to manually go into these systems and model or change an INI file, which meant that there's a huge latency between what was running and what we thought we were observing. And that wasn't only a problem because anything was basically a lie. The single source of truth was the biggest lie possible, causing a lot of chaos and distrust when an alert was triggered. Like, is it something real? Is something gone away? Is it something that we prepare to be there, causing a lot of pager overload. We were still monitoring symptoms. CPU is at 80%. My gut feeling says, because I was come out and had no background, CPU that's running at 80%, that's basically what we pay him for. Right? That's a CPU, it needs to work, and if it's not working, then we're actually wasting money. But historically, because we were monitoring symptoms, some grumpy bearded guy historically said, if my CPU hits 80% in the tech stack from 10 years ago, that was a signal that it was wrong. But now that we're changing so quickly, as I said, it might be that it's doing its job. The new application can actually handle a CPU of 80. It could be an alert that's gone away, and because the team that decommissioned the node is not actually the one decommissioning it from the monitoring system, and it's something, sync, Excel sheets. Tomorrow night, your system is going away in the monitoring system. As we all know, backups and syncs run at night. So poor Bill is going to get woken up at 3 a.m. by a sync. The result of a sync of something that happened yesterday. Bill is not going to be a happy bunny. So a lot of people actually didn't want to go do on-call anymore because there was a lot of BS going on. Right? A lot of false positives. And that's where we started thinking about how do other fields of technology do these kinds of things. And then we actually looked back into the 60s, where this is a definition we heard before, right? When people used to make things you could touch and sell, you had to solder them, there were circuits, you would have to package it up nicely, and then you turn it on and it didn't work. So the only way to do it is basically open it up again, get your little tools to measure the electricity between all your nodes. That is very destructive most of the time. So they came up with the idea of observability, making sure that when you have soldered the whole thing shut, that you can still have a couple of questions you can ask and make sure that the thing that you've just sold and may even have shipped far, far away. Because remember, this is the time that flying was quite expensive. So sometimes you sold something that was a couple of 1,000 kilometers away and it was broken. And the only answer you could give was, okay, ship it to me. I'll open it up, I'll check it, I'll put it back in place and ship it again. So they came up with an idea. We need to make sure that we can observe it from the outside without actually breaking the inside. So let's try and map that onto what we want to do. Of course, we want the metrics we had before, but we try and work out better indicators of what is going on. Try and get away from the symptoms, but when we still don't have an insight into the application, but we have or could have insights to the web server that's in front of the application on top of the OS we are running. So can we look at utilization? Can we look at error rates that are showing up in my Apache log? If you ask things like Apache and Nginx, nicely you can get things like latency. And of course, at this point, the internet really is a thing. We're all shopping online, and people are starting to get offended when a page loads too long. Companies like Google, AWS, they actually have metrics where they say if my page loads at twice the speed than normal, I'm actually starting to lose business. So we're trying to get these kinds of sort of relevant numbers, but still in the operations space. We're starting to think about logs not only as something we can look up centrally, because you don't have to actually go into all the systems, but they're also insurance as a reconciliation tool, where it's basically something we could replay to see what was going on, or heaven forbid, replay it in such a way that we can actually reconstruct things like databases or some form of shared history we base our billing on. As I said, our architectures have grown to the point of microservices, so there's a lot of tools that have a small function, Linux-like, right? One function, one tool. So we're also trying to work out where actually in our infrastructure things are breaking. So for that, the industry, we have come up with something called traces, where we can inject a trace ID in the entire flow, and we know how much time something has spent in a certain place of the whole workflow. And then we can compare the traces and the spans of what it took longer than normal, but we're still looking at sort of symptoms, right? Where something is twice as long all of a sudden. But now we can more easily find where the 2x was. So we, as an industry, we came up with metrics, traces, logs, 3 pillars of observability were done, end of presentation. But of course, I think Chris is in the room. Yes, tools are not going to fix your broken culture, right? We're still, as operations people, we're trying to get into the same room with the devs so they can actually explain to us what the application is doing and why is it failing, and or why am I seeing weird stuff inside my Apache logs. So we're still in operations world where we're not really want to go on call, because I don't know what's going to happen, don't know when it's going to happen. But as a group, we come, DevOps starts to become a thing. We do shared pain stories, and we're going to try and work out why that we're going to get more comfortable with failure, so we're not going to have this initial high adrenaline peak when we get woken up at 3 a.m. in the morning. And we're also trying to push back to this 100%, everything needs to be 100% up story. One way we do it as I said, we're going to do microservices. If one bit dies, then we have the other stuff that's still running. If we architect it correctly, that there's no chain reaction in our system. We're also going to push back on, we're going to deploy once 6 months, because then we only have one outage. It's going to take 2 weeks, but it's twice a year. Whereas we're going to say, no, we'll follow etc. We're going to deploy 10 times a day. The deltas are going to be really small, so if something happens, we open up our Git log, or SVN perhaps at that time still. Right? But the delta is going to be really small. It's 1 line, 2 lines, 3 lines, and that's going to get pushed. So we either roll backwards or we fail forward. So we're going to take the pain away for these operations team that are still on call at this point. Because we also want to go away. I don't know. Has someone in the room still worked at a NOC, right? Back in the days, we didn't even give people a pager. We basically paid someone to sit and stare at a screen for 24 hours. The people that like to work at night were the strangest people we've all seen, the IT crowd probably. It takes a special kind of people that are happily to work midnight to 8 a.m. in the morning on a Sunday and stare at graphs that hopefully do not change. As I said, be like Bill, right? We want to sleep. Like, my boss does not pay me enough. You do not pay me, well, my bosses are there, so you do not pay me enough to be awake on Sunday morning. I like to sleep, and if something really bad happens, the pager can wake me up. So this is a sort of definition I stole from someone called Julien Pivotto. Observability is monitoring minus the luck, right? We all got away with architectures that we knew were going to fail at some point. As long as it wasn't on my shift, I was fine. The luck was also in the fact that we do not know still what's happening in this application. Like, is it working? How many people are logging in? Is this a normal number of people logging in? I have no idea. So we need to find a way to get the luck out of our system, right? Build upon monitoring to get to something where we can actually observe on the outside. And then we came up with the following three things. We want to be data-driven at the moment because that's a new thing that came up. So we're going to have service-level agreements, also something that our corporate peers know something about because that's how they sell physical things. And basically, an SLA is a contract where two parties say, you're going to provide a certain service to me, and it's going to work 99% of the time. And if you break it, you have to pay some form of penalty, either in actual money or I'm going to get credits. And the next thing is we're going to have a SLO, a service level objective, and that's something that's a wish, right? We want to be up 99% of the time. But if we drop relying 99%, it's going to cost us money. So we wish to be above 99.9, the 3 nines or 4 nines. So we have a bit of gap between where we want to be and just before where we basically get punished. So the SLOs are your wishes, the SLAs are your contracts, and then the things we're going to observe, the SLIs, the server level indicators, like are your observations, and hopefully now we're getting to the point where we're going to get some actual observations, no longer symptoms, but we're going to look at revenue. We're going to look at other things that actually matter. Like, this is what the business is interested in. They're not interested in the fact that my hard disk is full. They're interested in the fact that they can no longer sell things while I fix his hard disk, and they're going to lose out on their bonus. So please only alert on SLOs. Ignore all the other stuff, but use SLIs to work out what your SLOs are. Don't forget the hard disk, because that's normally not really something that easily translates into something the business is interested about. And make sure that you can fix it. Your SLO is set at such a rate that you have enough time to fix it before you hit your SLAs. Right? If you're in retail, in America, Black Friday is becoming a thing in Europe. If you have a 200-day latency on ordering a new server and to it being online, while you need to buffer for a 2-day peak at Black Friday, you have a problem to scale up, right? If you you notice it's going to go wrong, yet the latency is off. So make sure that you set it at a point that you can actually react quickly enough. And at this time, we're also starting to communicate finally with our peers, our devs, and we're starting to instrument the applications itself so that it sends signals. This is a Tesla coil that sends electricity to over the air to places. So you can use electricity without having to plug in. So if Tesla would have won the electricity war, we'd have had wireless charging in the 1920s. Unfortunately, we got the Edison version, so we're all still on cables. But the similar thing is now happening at software. So we're going to instrument the code to send signals about its functionalities and its business indicators. Next, such as, already told a couple, right? Revenue. Amazon is interested in dollars per minute. That's their business. They can tell you whatever they want, but in the end, the web shop needs to have a certain revenue, number of sales, or if you're an event website like Meetup, right, then the amount of signups, or if you drop a bit more to the technical side, if your business is API first, right, you want to know how many APIs calls you do. And if you start more into the data side of things, you start looking at abnormal usage. That also has implications towards security, right? If I see a huge peak at 3 o'clock in the morning, but my usual traffic is 9 to 5, or people doing cheeky shops at the weekend, I know that might be an indication of a bad actor, a foreign nation trying to hack in. So it's not only money, but it's also security-wise, it's going to help us a lot. Whereas before, we just had these Apache logs that mounted up. But in the middle of the night, it could basically be that our backup script was running. But now we actually have, in the application, we have a notion of what is happening. And this is the bit I'm very, very happy about. We've finally got to the point in monitoring observability where we are converging again. Before, you had a metrics tool that could only deal with its own metrics. We had a logging tool that could only send its logs to its own tooling. There even was some business sense to it. Like, I have a commercial tool that starts with an S, and I can only send my data there because my business model is you pay per metric or per log. Whereas now we have an open telemetry project that basically says we have a standard, and tools are starting to adopt the standard, and I can basically send my metrics logs anywhere as long as I use a library that deals with this in this format. So we're finally going to have convergence in the ecosystem, while we also have colleagues that tell us real numbers and no longer symptoms. So I'm going to go full circle. I'm going to give you my definition. It's not only removing luck, but it's monitoring plus DevOps is observability, right? We discussed culture. Ops doesn't want to do it alone. We've discussed automation. We have our tooling, but it was always manual. Now we have things like Prometheus doing service discovery, and it's finding the things that our colleagues have put in place. We're measuring pretty much anything still, but in a better, healthier way. And we're actually sharing again. So we have our full cams now in our monitoring stack, and that to me is observability. So thank you for joining me. If you want to talk more, that's my email. If you want to rant on Twitter, that's my handle. And if you want to see the slide deck again, it's on SlideShare again. And I'm being called off, so if I have any questions, I'll be around in the common area.
Thank you so much.
Thank you.